Awesome. Welcome. My name is Paul, and today I'm going to tell you a bit about how we built a data lake without trying. It's a bit of a story, so thank you. Thank you for listening. Thank you for joining in. Just who am I? Sorry, I've got a switch here. My name is Paul. I'm a technical lead at Synthesis. I've been known to know stuff about AWS. I'm a recovering electronic engineer. And then I tinker a bit with stuff, and I write a bit of code every now and again. That's who I am. My Twitter handle is on there if you want to follow me. That's also my username in GitHub. Yeah, so that's me. So let's get started. So how did this journey begin? So we met a client, and the ask was pretty simple. They've got a ton of data sources. They're ingesting all of this stuff manually, and they've got some issues with data quality. So they had all these sources that they wanted to consume, but given some constraints, both from a human resources, but also from an infrastructure point of view, they had a big data warehouse, and this thing was a bit of a choke point for them. So that was a problem, and everything was manual. So they had to extract data manually. They had to build their dashboards, and these reports they were building were quite business critical, but they could only refresh them once a month, which was a bit of a problem. And they wanted to go from monthly refreshes to weekly, daily, and maybe even real time, if the source systems allowed it. So the client's problem was like, we've got a big data problem. And after sitting with the client a bit, we realized maybe they don't have a big data problem. Maybe they just have a big problem with data. And that's how that's how the entire thing started. So we sat with them, and we now have to figure out how do we solve this. So the client had a big on-prem Hadoop cluster, which we could use. They also had they also were using AWS, and they were connected to the AWS environment was connected to their on-prem environment with direct connect, and it was quite a mature AWS environment. So that was pretty cool. One of the constraints we had was that the client team, they were not technical at all. They were a bunch of data analysts, very good ones, but they weren't programmers, they weren't data engineers. So these things we had to work around, and the ask was that we built something that's quite low maintenance that they could possibly run with themselves when the engagement ends. And then we also said, like, maybe we shouldn't be building something for the entire organization. Maybe we should be building something that meets their needs. And we cherry-picked a handful of sources that we wanted to start with. So given these constraints, we set out into AWS, and we said, okay, cool, what can we do? What can we do that's pretty low maintenance? And that's serverless. Like, we thought serverless might be a good way to go. So we came up with this architecture. It's not the full one. There's a few more moving parts in them. But we feel like this might be good for them because it's functions as a service, S3, and the Glue service is pretty cool with QuickSight and Athena all being serverless services, which is pretty low touch. So if you're not familiar with Glue, it's a pretty awesome service from AWS, which has a thing called Glue Jobs, which is very similar to Lambda. Only difference is it can run days instead of just minutes, and you get the full Spark core with Spark SQL and Spark data frames and all the good stuff that comes with Spark. There's also a Glue context, which is a bit of a wrapper around Glue, around Spark, to help you interact with other AWS services. So it's pretty handy and very, very easy to use. There's also Glue Python shells, which is basically a Python Lambda that can run for very long. And then Glue has crawlers, which in theory allows you to point a crawler to a S3 bucket containing any data, and it will figure out the schema of the data and write that into a Glue catalog, which you can then query through services like Athena, QuickSight, Redshift Spectrum. You can point to that bucket and to that catalog, and it will just work, which is awesome, because that's the promise of data lakes, where you can just drop anything in there and it will just work. And then to orchestrate things, we wanted to use AWS step functions, which again is a serverless function or serverless service. But unfortunately, being a big enterprise, services need to be whitelisted, and that service wasn't whitelisted at the time when we started. So you said that that's not a problem. We can hook into a bunch of CloudWatch events and use Lambdas to orchestrate data coming into a bucket and ending up into a data catalog where our analysts can start working with the data. When we set out, we said, okay, cool. We already have a process to get data manually, even though it's just, even though it's once a month. So let's continue. Let's not focus on extracting automatically, but let's get a good pipeline first. And so we would still drop data into our pipeline manually. And we still had a bit of a manual step at the end in our catalog where our analysts just had to double check that our Glue jobs and our ETLs are doing what they're supposed to do. So wasn't the perfect solution, but it was a good starting point for us. And being devs, we do everything infrastructure as code, and we coded out this pipeline. And what's awesome about that is we could spin up hundreds of these, test stuff, kill them again, iterate over them. What we like to do is we like to version our Terraform, in this case it was Terraform, version our Terraform modules like we would any other code, because there can be bugs in your infrastructure. There can be new feature releases that's backwards compatible, or there could be major changes to your pipelines. So we felt that, and that's the way we go. So this example here isn't the exact one we did, and the exact one's a bit more involved, but this is this gives you an idea of what a pipeline could look like. So at the end of I think it took us about 3 weeks to get the first few sources in. We had a few outputs. So the first thing we had was this disposable pipeline that we could just chuck away and create new ones and ingest data. And we've got basic ETLs that does a bit of data quality checks and cleanups, which is pretty awesome. And then we had some historic take-ons for some of the data and kind of frequent-ish extracts, not just once a month, because now the analysts didn't have to do all this data checking and all this data movement. We were doing this for them, so they had a bit more time to go and extract the data more frequently. So even though this pipeline it was still quite manual, we already saw improvements in how frequently we could get data into a state where they could use it and start pulling up dashboards. All our data was in a queryable format in a Glue catalog, so they could interact with it using Athena. And we had some basic dashboards running in QuickSight. So that was a massive win for us. And quite early in the project, we saw that. So the learnings we got from this first phase, like I say phase as if it's like that, it was 3 weeks, was Glue jobs are queued. Initially, when we started, we didn't know this. We thought they behaved like Lambdas, where you call it and it runs. So this is something that we had to keep in mind in you submit a job to Glue and it could run in the next 2 minutes, or it could run in the next 10 minutes. The longest we found it was about 10 minutes that you had to wait. But that's something you need to know about Glue jobs. Today, Glue jobs there's a streaming Glue job that's in preview, and that might change things a bit. But we don't know much about the service just yet. And then Glue crawlers weren't as cool as we thought they would be. They would do weird things because they're not really configurable. You just point them to a bucket and you point them to a Glue catalog. like a database, and it'll go create tables in there. And what we saw is if there's a bunch of schemas in the bucket that you're crawling, you get a weird behavior. So it wasn't like, you can't just point it to a bucket and get queryable data. And obviously it can't do any type of like file format. And then Parquet as a file format is super cool. We converted part of our ETL jobs, convert everything to Parquet, and that makes Glue crawlers much better, because it's it's a file format that Glue plays with quite well. And a lot of big data tools out there work well with Parquet as well. In addition to this is when these Parquet files get written, they get zipped. So there is a bit of savings on your storage, but also on your querying the data using Athena and QuickSight, because you're querying a smaller file. So there's quite a bit of savings in there. And then obviously our orchestration needed quite a bit of work, like orchestrating or figuring out where you are when you've dropped a file and where you are in the pipeline could get quite hairy, like because it's just like a bunch of CloudWatch triggers and lambdas running. So that was a bit weird and not ideal. But like even at the end of the 3 weeks, we still didn't have access to step functions, and we decided we'll continue with this for now, even though it's not that great. So after the first phase, we said, okay, cool, we've got something that works, and it seems to improve, even in this quite crude form. It seems to improve the analyst's life, and we can push out reports more frequently. So let's see if we can make it better. Let's see if we can automate some stuff. Let's automate the ingestion of data. So that was our goal for the next phase. So we looked at our pipeline and we said, okay, we're happy with it, like for the most part, we're happy with it. So let's take these core components and package that as a pipeline. And then this pipeline could be treated as a little black box. You just feed stuff into it, and it does its job, and it writes out to it ends up in a catalog. So how do we automate the ingestion? Like what tools do we have in our tool belt to do that? So we started looking at some services, and AWS has a ton of services that you can do it with. You can do it with a plain old EC2 and just run some stuff on it. But again, we wanted to do, we tried to stay as serverless as possible, like low maintenance things. So File Gateway is a pretty cool service, but that would still, that needs quite a bit of work from your on-prem team, and you would still end up relying on other people dropping files into a network share. So it's like, okay, cool, maybe that's not that great. EC2 batch and EMR, awesome services, but they're a bit more involved, getting your extract jobs running on them, and you end up actually managing service. So we said, okay, cool, let's park that for now. And given that we only have a handful of sources, they run on quite beefy machines, so we felt like that maybe is not the time for EMR at least. Then DMS, database migration services. That's an amazing service, and we thought like that's the one. We will point this to any SQL database on-prem, and it will start extracting stuff for us. We'll get change data capture, all the good stuff. Unfortunately, this is one of those services that was also not yet whitelisted by the client's cloud team. So we had to park that idea. And then Lambda, I mean, like Lambda is the Swiss Army knife of AWS. We said, like, let's give it a go. And usually Lambda is frowned upon if you do kind of long running tasks. People think of Lambda as something that can, like, you think of milliseconds. And when you get into the minutes, it's frowned upon. But we found that running a Lambda, even a 10-minute Lambda, ended up cheaper than having an EC2 that you had to like you really had to be quite strict on yourself to get to optimize from a cost optimization point of view. And then a bit later, we discovered a little hack with Glue. If you need like a long running Lambda, you can take a Glue connection, which is a thing to tell Glue you want to connect to something within a VPC, and you attach that connection to a Glue job, which basically puts your Glue job within a VPC context. And then you can, if like in our client's environment where your VPC can be hooked up to on-prem, then you've got a Glue job, something like a Spark or a Python shell job that can run for hours and is on the network. So that we haven't used it, but that's a pretty cool hack that we came across. The Glue connection doesn't actually have to work. Like you can have some mock, it can point to some mock database with some mock credentials, and it will still create the ENIs in your VPC, which your Glue job can attach to. So that's a pretty cool thing. Okay, so Lambda. That's the way to go. So our pipeline now has Lambdas sitting in front of it, and those Lambdas would extract from SQL databases, RESTful APIs, even SQL databases where we had to authenticate using Kerberos tickets. That was pretty cool. We created custom Lambda layers that understood Kerberos, which is pretty funky because Lambdas aren't known for being good at domain joining. So we could hook into databases that we only had service users for, where we didn't have a username and a password, which is quite common. I think in an enterprise environment, getting username and passwords is the exception. So now our Terraform looked a bit different. So we wrapped our initial pipeline in another module, and that module would just handle the ingestion portion. And all we needed to give it is point it to a SQL database, give it a script that we want to run against that database, and it will take care of that. It would create a AWS secret for you in the background that you had to manually go and populate, because we don't like putting secrets in code. I think that's a pretty common thing we don't like to do. So, and we could take this now and copy paste this and have many data pipelines. So now that we started ingesting a ton of sources, we started realizing like maybe our pipelines aren't that robust because schema changes, and we weren't planning on schema changes. We thought like, what's the odds of someone changing the database schema? It happened. It wasn't a frequent thing, but it did happen. Things like a column being added or a column being dropped, which is pretty simple cases to handle. The harder ones to handle was data types changing and columns being renamed. But luckily we had Glue. I mean, because Glue could take care of all this stuff. So we thought. So I'm going to show you two examples of where Glue, where the Glue crawler kind of did some weird stuff that we didn't like, and how we remediated that. So I hope you can see this. It is a bit small, but we had it. This is an example of a data set that was indexed by a crawler, and it sits on the Glue catalog. And then I added a field in. I added a string field called name. And then if I go into a theta and I do a select star on that database, you'll see at the bottom that name is Paul, Josh, and Gert, and the other ones are blank. And that's Glue being clever and figuring out like this column wasn't there, so I'll just populate it with some default value. And that's okay for many cases, but we really didn't like the fact that we couldn't control what that default value is. And it could populate it with a valid default value, which we also didn't like. So we thought, okay, we want a bit more control over what's happening here. But then like a worst, like what could happen that's pretty bad is, in this example, I went and I changed the data type. So it was amount, which is a double, and then I changed it to a string, which is like probably a bad example. Like you won't have an amount field turning from a double to a string, but I did it. And this is the kind of thing you get where the underlying query engine, which in this case is Hive, just completely breaks. You can't query the data anymore. At least you can't query across those columns anymore. So amount, you have to query the data up until the change, and then after the change, you have to, like, you can't have a window that spans across the change, which was a problem for our data analysts, because they like, we understood now, okay, cool, like, something changed a week ago, so up until a week we could create like that, but I mean, like, this is not usable, and we needed to fix this. So what we did is, from day one, we had partitioning within our buckets, which is basically just a folder structure within your buckets. But what this allows you to do is, when you write something like an Athena query, and you query on those partitions, it'll only go and look up the data in that directory, saving you a ton of money from when running these type of queries. So what we introduced is a version. So we would version our ETL jobs, and the ETL job would enforce a schema. A very light enforcement. It wasn't hectic to begin with, but this would allow us to, if a schema change happens, that our analysts won't end up not being able to work. So they would continue querying version 1 of the data, and we will work in the background to create a version 2 for them if an input schema changed. And this saved us. Like, this really made our pipelines much more robust. So what it looked like at a high level would be, you could run multiple versions of a schema, and it would write to that partitioned bucket to the corresponding version. And then, depending on what changed on the input schema, you could run these different versions indefinitely. An example of that would be if you decided to repartition your year, month, day. You want to partition on a different date in your data set. You could do that, and those two versions could run in parallel indefinitely. Or you could stop running a specific version, and then we had the option to say, how do we backfill the new version with the old version's data? What's the default values we want to put in? But we were in a bit, like, it's a bit more work for us, but we were totally in control of how would we proceed with this. And this really, like, this was quite a big change we made. But this is the way we run it now, and it's proven quite successful. So after this phase, we had a bunch of outputs. Like, the biggest one arguably would be it was a little Python script that we built that could handle how we do schema evolution and how we version our stuff. This was very important, and when we roll this out at other clients, this is something that we take with. Like, we feel this is very important to do this. And then we automated a ton of sources. Like, we saved a bunch of time for our analysts. They didn't have to go and extract stuff manually, even though we still, like, to this date, have 1 or 2 manual data sources where people, like someone with an Excel spreadsheet on his desktop, can go and drop that in for us. But the bulk of them were automated, and there was some basic data quality and data health checks built into the pipelines, which we were very happy with. So the learnings from this phase was glue and schema evolution. And I say glue, I think it's probably every system would have this, every technology would have this problem, but the schema evolution and how you handle that, doing that in an automated fashion, isn't quite there yet. We enjoyed the control we got from schema versioning. And then, like, partitioning your data is just a must. As we started onboarding more and more data sources of varying sizes, we realized that without partitioning, our cost of querying this data would just skyrocket. This would kind of make the project, it would blow the cost out of the water if we didn't do that. And it's such a simple thing to do. So, like, after this phase, we had something that met all of the client's needs. We could go and we could do daily refreshes and all that good stuff. So like the result was we kind of built a data something. Like we don't know what to call it. I know it's like, this is my only meme, but if it quacks like a data lake, like it's not actually a data lake. If you look at what AWS says about what a data lake is, it's like this centralized thing where you can drop data as is, and you can do real-time analytics on it as well. So I'm just highlighting some of the stuff that I feel like this is not what we built. We didn't build a centralized thing. We set out to build something for a specific team, for a specific business unit, to serve their needs. Even though it follows common data lake patterns, it's not a centralized thing. We quickly found out that storing data as is, just chucking it into this machine, and it will just magically get your data queryable and usable by the organization, is not true. Not having that, something simple like that semantic consistency across your data makes it very difficult to use that data. And this data lake, like data lake patterns in general, assumes that your consumers of your data lake are quite like highly skilled data engineers or data scientists, because they have to do quite a lot of work to make this data usable. Again, not what we built. We enforced schemas, and we were quite strict on that. We can't just chuck anything into our data lake. And then the real-time analytics, like I don't think data lakes are great at that. They are very good at running batchy analytic jobs, training models on it, but the real-time analytics, I don't think the traditional data lake model fits that very well. So in my opinion, I don't think we built a data lake. If we look at what James Dixon coined the term data lake in 2010, the idea was that data lakes are these small disposable things that individual business units can run, and that a bunch of data lakes together form a water park, or like some random term, which, looking at what James Dixon meant with when he coined the term, yes, I think they were pretty close to it. But looking at how data lakes as a term evolved over time, I don't think in today's context we actually built a data lake. We built something. We built a data something. So today the project is healthy, running. They've got close to 50 sources that they're ingesting. Daily dashboard updates, which is amazing. Still no real time yet. The data sources they're ingesting is batch updated in any case, so real time wouldn't, like there wouldn't be a ton of benefit from that, but it's daily, which is super cool. And the analysts can focus on what they're good at, like extracting value from data, not wrangling data and moving data from point A to B. Like let these pipelines take care of that. Then this platform is serving across the organization, even though we built it for one business unit. A lot of people are consuming it, and this is where we're really happy with what we've done, because taking a software developer mindset, versioning our code or our modules, versioning our data, doing almost like unit test-like things on our data means that we can, like, this thing we're putting out, the data, the product we're putting out is solid. People can reliably point at our data sets and query it, and they'll get the same results every time they do it. And then we've built a repeatable pattern for the business. So if other business units want something like this, they can totally just lift and shift our code, point it to their data sources, put in their ETL logic, and they can have it. They can have it like as well. Like they don't need to rely on us as a team to go and build it for them. And this can only actually be done using technologies like infrastructure as code, something like cloud, where infrastructure, you can have infrastructure at the click of a button. And I think given the technologies we chose as well, this is not an expensive thing. I think traditionally, if you had to go and spin up a big Hadoop cluster, it's an expensive thing to run. So people tended to kind of want to centralize that. The same with the big data warehouses, where this is using dirt cheap storage, using serverless functions, so you don't have this compute that's constantly being built for. I think this is a pretty repeatable pattern and a good pattern to decentralize across your organization. So what we're looking at going forward on these on this project and on this pattern is incorporating streaming data sources. I think that's where the world is going. I think actually that's where the world is. It's not where it's going, and we need to move with it. So how do we bring in streaming data sources into this like kind of data lakey world? And then we want to look at enhanced ways of doing data quality checks and checking how data quality moves over time, and like less static checks and more data quality checks that grows with your data set. So that's what we're working on today. So looking back on the project, there was some good stuff, bad stuff, and then there was some pretty awesome stuff. So some key takeaways from this, and this is not just on building this type of project. This is in general, like some takeaways from this and stuff that we try and live by, or at least I try and live by, is like the first thing is try and follow the money. Find that thing you have to do to show value in the project as quickly as possible. For us, that was cherry picking a few data sources that had the most value and building pipelines just to get them in and give the client the benefit of actually like making this investment into the project. And for us, that was 3 weeks in, and the client already started seeing value. And that's like, I feel that is very, very important because you've got the backing of the client, and they're now invested in this thing, like because there's value in it for them. So the feedback you get is just so much better from the client. So this is something that we try and do in all our projects, not just this type of project. And then this is something that is actually like when I read it, it's more for myself, but it's like, get over yourself. Like, we're devs and we try and do the coolest stuff and put in the latest technologies and all that, like all those shiny things. Like, keep it simple. Like, get to that value point first. Make sure that you put in proper processes, like this operational excellence idea. It's very hard to change a bad process, but it's like quite easy to swap out a technology. As techies, that's kind of what we do. So once you've got like a good process going, and that can be like in our case, we work in an agile way, and we've got the agile ceremonies, and we've got engagement from a product sponsor, like those type of things. Like, get that solid early. The way we onboarded a source, like that process, get that ready, because you can always swap out the tech later on. And we have, like, during these processes, during these projects, we have swapped out tech as needed, and the business, like the product still looks the same on the top, at the surface, even though we've swapped out quite a lot of stuff underneath. And then the third point, which I don't know actually why I put it in here, I don't know where else to put it, is and this is specific to this type of project, is you've got stateful elements, your S3 buckets. Try and get them quite solid early on, because you don't want to end up having to delete the S3 bucket with a ton of data in it. So for us, it meant hoisting the creation of those things out of your core pipeline code, so that you can work on your pipeline without affecting your stateful pieces. But yeah, so this is something that was quite important. And the next, like, tooling can be, like, new tooling can be pretty scary. For us as techies, like, we get excited with the idea of having to use, like, learning a new skill or picking up a new technology. But for our clients, like, they are, like, in this case, there were a bunch of data analysts that was very proficient with SQL, and that's the world they lived in. Now we required them to look at things like Spark and Athena, which is still SQL, but it's not MS SQL, or it's not a specific flavor of SQL. It's actually no flavor, and that's a scary. And we tried to take the client and take the team with us along the way. We had a ton of demos when we write ETLs, where we translate old SQL scripts into Spark jobs. We would sit there with them and we would run it past them. At one point, one of the team members, so I focused on just building pipelines and doing the automation, and my colleague Teddy, he embedded himself as a teacher in the team, and he would pair program with the analysts and do and I think today most of them are quite proficient in Python, guys that just a few months ago could only do SQL. So I feel like that's very, very important. Take the client and take the entire team with you on the journey. Repartitioning is okay. We had to do it because you don't get it right first time. We had data sources where we thought the last updated date would be a good date to partition on. And then we found out later that actually the date at which this data was extracted had more value to the client. And we had to repartition data. And that's a simple glue job or Spark job to just repartition that. And that's okay. Like, it's fine. Just like, yeah, nothing actually much more to say there, but yeah, so it is okay to repartition if you don't get it right. Unfortunately, in the data lake world, it's not as easy as in the SQL world. You can do that in a much more automated fashion. There is a bit of work involved, but I think it's cool. I don't think it's a train smash if you need to repartition data. What's cool about the versioning is you could have a new partition under a different version, so you won't even affect your end consumers or your consumers when you do that. And then schema changes, like figure out how to deal with it quite early on. This bit us quite hard. When we started onboarding a ton of sources, we didn't anticipate this. Today we know it's an issue, so we bake it into everything. But be sure it will change. If there is schemas, they will change. So, and you don't have to build this elaborate thing to handle it. Even if your pipeline just breaks, if the schema changes, that's okay. But once you start slipping through or bad, not bad schemas, but the schema that's not like you don't have a version and you don't control the schema flowing out of your pipeline, you are going to run into problems down the line. And you might not run into them day one. Usually these things manifest at the worst times. So have a way to manage or to at least detect schema changes. And like a general thing is, don't underestimate Lambda. Lambdas are flipping awesome. They can, like, running for 50 minutes is a lot of time. You can get a lot of stuff done in 15 minutes. And then Lambda layers are amazing. They allow you to extend the capabilities of Lambda endlessly. I mean, we had Lambdas, like I mentioned, running Kerberos, authenticating using Kerberos tickets. There is really no limits to what you can do with a Lambda layer. I think if you really wanted to write a PHP Lambda, you could totally build a Lambda layer that would allow you to write PHP Lambdas. I don't think anyone has done that, maybe for a good reason. But yeah, so Lambdas are awesome. Don't be afraid to use them. Like I mentioned earlier, for us, swapping out Lambdas, like chunking our Lambdas together and putting it rather in an EC2, you have to exactly right size that EC2, and you have to orchestrate your jobs in a certain, like exactly the right way to have your EC2 actually run cheaper than your Lambdas would have run, even though they're quite long running Lambdas. So Lambdas are really, really awesome little tools. And then Glue, as awesome service as it is, it's not cheap. You have to really watch your Glue spend. The defaults that a Glue job comes with is pretty mad. It is 10 DPUs, which is massive in the Glue world. And its timeout is something like 48 hours. So a 10 DPU glue job that runs for 48 hours will bankrupt many people. So be aware of that. Like when you spin up a glue job, don't just go with the defaults. Figure out what you need. We had jobs that were, there's a minimum of 2 DPUs you need. And for most of our jobs, that was sufficient. And then every now and again, you get a job that is running close to those limits. And then we would just alert on a job that is getting close to the limits of, or the limits we've set for it. And then we would just go and amend that. We had a runaway job where we failed to catch an error correctly, and the job would spin up for a minute, die again, and you get charged for 10 minutes. Spin up for a minute and die, and it went on for that, like that, for an hour before we caught it. And that was quite a hefty bill we got just by that little one glue job. Luckily for us, they are queued and they don't spin up immediately. So it wasn't a complete train wreck, but it was a bit of money that went into that. And then glue jobs, the Spark flavor, not the Python shell ones, you do pay for the first 10 minutes if you use it or not. So try and use it. Like don't spin up your DPUs if you're still under 10 minutes. Rather have your job run a bit longer than pushing this thing to execute under 10 minutes. So 10 minutes is that sweet spot. And then if you have a very small job, don't use the Spark jobs, use the Python shell jobs. You can import things like pandas, and you can, we're actually doing that today at one of our projects. We've switched the bulk of our glue jobs are now running Python shell, which is build per minute, and you can run less than 1 DPU. I'm not sure how low you can go, but you don't have to run a full DPU for those jobs. You can save quite a bit of money when doing that. And then the last thing is, when you're building these type of things, data is your product, and like data quality and actually just quality in general really does matter. Like your end consumers, they want comfort that that what I got yesterday out of the system, I'm going to get today and I'm going to get tomorrow, because the guys are building business critical reports and they're training business critical models on this data. So treat it as your product. Like treat this thing as a product, the same you would if you built a RESTful API. Like really, like this thing is like the data sitting in there is the product. That is what you're building. The pipelines are irrelevant. Everything before the data is really irrelevant. That's just the way you get it there. So really focus on getting your data out in a repeatable manner, and treat your consumers as your customers. That's like that's the mentality we followed, and we've really reaped the rewards from doing that. And that's my talk. If you want to join the Synthesis team, drop us a mail at talent@synthesis. And yeah, thank you very much for tuning in and listening to me. Yeah, if you've got any questions, you can pop it through now. I've got the Zoom chat open.